Okay, this is question number 15, the last question on the multiple choice, and it says, a pulley has a diameter of 20 centimeters, so from here to here is 20 centimeters. It takes 5 seconds for 50 centimeters of the belt to go around the pulley. So what that means, you can visualize it as, let's say this pulley is rotating this way, right? So it's going around this way, let's say. So there's belt going around it, maybe more than once, we don't know yet, but it's going around it, and when we have 50 centimeters of the belt, it's gonna the time it takes to go around that is gonna be 5 seconds. So that's what I wrote here. And then the problem is asking, find the angular speed of the pulley. So that's what we're trying to find. I always write down, what am I finding? You know, I write it down on the side, not part of the word problem. That way I can always refer back to it very quickly instead of having to read the whole problem again. Okay, so that's what I'm writing here. We're finding the angular speed of the pulley in terms of, so the units are very important, radians per minute. Okay, so notice how we're giving things in units of centimeter and second. So those seconds are going to probably have to be converted to minutes. Somehow the centimeters are going to have to be converted to radians. So right now, I'm not sure exactly how the steps that I'm going to work through are going to go, but I'm going to go ahead and start writing things that I know. And then eventually you kind of get to the point where you get to your answer. So let's write, for example, what we're given, right? So the diameter is 20 centimeters. And if I know I want to go around this thing, I have to find the circumference at some point, because I want to know how many times I go around. So circumference, because the belt that's 50 centimeters is going around the circumference. And so the definition for this is 2 pi r, which is the same thing as pi times the diameter, because the diameter is basically 2 times r. Okay? So since we're given the diameter, I could plug it into here and get 20 pi, and I'm going to write my units, because remember, these are very sensitive since we're looking for specific units and they're changing, and we're going to have to change them. So we plugged in a diameter that was centimeters, so that's all we have to write down, centimeters. And so now let's write what we know, 50 centimeters per 5 seconds. Okay, so I'm going to go ahead and write 50 centimeters divided by 5 seconds. And the reason why I'm doing that is because I see that the unit of time is on the bottom here. So I want to put that on the bottom too. And so it's kind of, this is a velocity, a linear velocity, not an angular velocity, which is what we're looking for. So we're going to get a linear velocity, and with the circumference, we're going to convert that into a angular velocity. So here, first of all, when I get rid of the seconds, because I want this in terms of minutes. So I need to write something in terms of second here, and the minute on the bottom, so that way I end up with minutes and the seconds get to cancel out. So basically playing a game of units a little bit in this problem. So I know that for every 1 minute, there's 60 seconds, okay? And I'm going to go ahead and divide the 60 by the 5 first, instead of multiplying and dividing, because it seems a little simpler to do. Or I could also choose to divide the 50 by the 5, which is even simpler, because now that just gives me 10. And so 10 times 60 is just adding one more zero to it and getting centimeters per minute. 600 centimeters per minute. So I'm very close in that the bottom unit looks the same, but I need to match the radians as well. So this is really 20 pi centimeters per radian, per 2 pi radian. So one of these, if I go around it once, I'm going around it 360 degrees, right? Because if I go 180 degrees, I basically make half a circle. Another 180, I make the full circle. Adding 180 plus 180, 360, right? So I went around it 360 degrees, which is the same as saying 2 pi. Okay? And this is just a dividing line. So basically, for every 20 pi of circumference, I've gone around it 2 pi radians. Okay? So now what that means is that, I'm going to do it over here. I have 600 centimeters per minute, and I need to cancel out the centimeter for a radian. So to cancel out the centimeter, I need to put centimeters here, and I need to put radians here. So basically, the radians are on the top, so the 2 pi has got to be on the top next to its radians, and then the 20 pi has to be next to the centimeters. Okay, so that way I can cancel out this centimeter unit with that one, and finally get radians per minute like the question was asking. So now it's a matter of doing algebra. The 2 pi's cancel, first of all. I can cancel this 2 with a 20, and I get 10 on the bottom, so that my final answer is 600 divided by 10, which is 60. Everything else canceled. Radians per minute. And so that answer choice is C. So this is answer